Okay, I think I might be live. Let's find out. Hello, if you're watching the online open day virtual experience thing. My name's James, and I'm going to do a maths workshop with you today. Sorry, I'm a minute or two late going live. Had a problem with the audio. Please let me know if you can't hear me. Although if you can't hear me, then I'm not really sure how you heard that request. Lovely to have you with us, assuming you can hear me. I'm going to talk a little bit about the maths admissions test, if that's all right. We're running this as part of the online open day on the 17th of September, and if you're watching live, there's a Slido where people have been asking questions. It says admissions Q&A, but you can also use that during this session to ask me about the mat questions that we're doing, and I've got a couple of live polls. So that's somewhere on the virtual open day page. There's a Slido event if you want to join in there. Right, I'm waiting for someone to tell me that I've messed up all the audio and they can't hear me at all, but hey, let's just start talking and see what happens. Okay, where are we? Good. Somebody's asked a question about personal statements, which I'm going to come back to when I get a moment. This is the old setup, by the way. I've had to switch back to my old live stream setup where I'm a tiny square down in the corner. It's all old and different. It's like getting back into an old car. Okay, let's go. So first, I made a video about general mat advice that you should watch before watching this one, ideally. It's got general information about what the mat is, what's in the mat, what the questions are like, and that's got some sort of general advice. If you've got general questions about the mat, then that would be a good thing to look at first. Okay, so I'm going to assume that you've seen that video, or at least found out what the mat is. That's the mathematics admissions test that's used by Oxford. If you haven't seen that video and you don't want to watch it now because you're watching live and enjoying it, then here's a quick summary of what's in that video. It's only about 10 minutes long, but here's a quick summary. The advice about how to prepare works like this. One, there's a very short syllabus, of maths that we expect you to know for maths. Have a look at it, try and find the syllabus, I suppose, and have a look at it. There are some practice questions on the mat website. Try some short questions, try some long questions, and then stop doing mat questions and do something else instead. Somebody in chat says, how do I join the Mat Admissions live chat? And I'm going to say, you're in the right place. And hopefully that starts to sort of flood. SB is also here. Hi to SB. Quick shout out there. Okay, brilliant. And because people are posting in the chat now, I reckon that I've got my microphone switched on, so that's good to know. They would have told me by now, right? Hello to an anonymous person. Oh no, it's Pan. Hello, Pan. Right, good. Okay. So the mat's got these short multiple choice questions on. And it's got these longer questions where you show you're working out. Today, we're going to look at both of these, and I'm going to suggest some resources where you can find the other things on this list of how to prepare for maths. Okay, so here's my one-stop shop. This is my website for maths stuff, things that you might want to know about maths. So it's www.maths.ox.ac.uk/r/mat. That's got the syllabus on, the one page of maths that I expect you to know by the time you do the mat. It's got some practice questions that I wrote and some past papers. And we fleshed that out this year, and we put that together into a new programme that we're very excited about. Sort of new. We ran something like this last year, but new in a new updated format called the matlive stream that is a lot of fun. It's about building problem solving skills for mathematics, and it consists of 10 worksheets that have some revision material for A-level maths or equivalent, some warm-up problems, some past mat questions with hints, and every Thursday we're going live for a live stream, a bit like this one, talking about maths problems. So we're going to look at things like that. And Payana asks in chat, are we going to do the same questions as yesterday? And the answer is no. I've got completely different questions today, in today's math workshop, that are not in any of the matlive stream sessions. So if you want to look at the questions that we're using for that, they're different from the questions that I'm going to use today. Okay, there's quite a lot of past paper questions that I can use for things like that, like this, which is very nice. Somebody went on the matlive stream website, they say in chat, and saw that one of their comments was added onto there as a quote or something. Oh, brilliant. Okay, I like adding quotes from things people say in chat as well. Especially people in chat are very clever, they answer the questions. It's a really nice atmosphere of having other people around live doing mat questions with each other and with me. Right, okay. And there's a question about interviews, which I don't know if you want me to answer live or not. Interviews are online this year, and you don't need to be good at using tech or applications or anything. We expect you to do the maths like normal, as if you were in the room. We ask you a question, you answer the question, maybe write something down, either on paper or on some sort of tech solution that we've got. But yeah, you don't need to use websites and applications and technology and things. It's still a sort of a non-calculator experience being interviewed, even though we're interviewing you with technology over the internet. Right, okay, not interviews now though, it's supposed to be Matt now. Okay, so I've done my trailer, I've done my advert for the Thursday sessions, completely disjoint from the Matt that we're doing today. It's my advert for the Thursday sessions, which really, if you take anything away from today's Matt workshop, it's that we do something a bit like this, but much more structured every Thursday over on that website. Okay, right, good. That's got examples of past Matt questions. What do past Matt questions look like? Well, they look a bit like this. I'm going to spend the rest of this time, having done 9 minutes of setup and talking about what the Matt is, I'm going to spend the rest of the time trying to do some Matt questions with you. I hope that's all right. Who have we got here? We've got a few people here. We've got about 50 people live. That's quite exciting. Always nice to see people in the chat and online. Here's a multiple choice question. It's in a format that I quite like, where it's a curve sketching question, but how do you do a curve sketching question on multiple choice? Here's how we've worked out how to do curve sketching questions on multiple choice. We give you a graph to sketch, and then we ask you which one of these options is the right curve. So your strategy could be go and try and sketch this curve yourself, and then see which graph matches up with it. Okay, and it's multiple choice. This one's from 2011. It has 4 options. These days we have 5 options, but same idea, it's a multiple choice question. And people are suggesting in chat, brilliant, I love this, people are suggesting answers. I've got a poll for this, I'm going to turn a poll on. Yeah, let's do a poll, there we go. Answers and also reasoning. I'm always interested in the reasoning or the reason why you get there. Except, I suppose, when it comes to marking the actual mat, because marking the actual mat, the multiple choice questions, you get 4 marks for a correct answer and 0 marks if you leave it blank or put a wrong answer. So no marks for working out on these ones. But I do want to talk about the working out. Okay, the people are voting at the moment. I've switched on a poll in the Slido. I'm really sorry to all the people who... Hang on, this doesn't make sense. I'm really sorry to all the people who are joining in on the open day but not watching this live session, because there's now a very strange poll that's appeared out of nowhere. Okay, but of course they're not watching this, so they didn't hear the apology. People in chat want me to try subbing in values. Belinda wants to sub in x equals 1 and x equals 0 to find out what happens. I like that idea. So if I plug in some numbers, this could be a way to eliminate options. Because it's multiple choice, we can think about eliminating wrong options. I see. When x is 0, y is 1, so that's not this one and not this one. That's pretty good. Okay, good choice of numbers, Belinda. If we plug in x equals 1, then we get 1 minus 1 minus 1 plus 1. We get y equals 0. So that looks a bit like this one. In fact, and not like this one. I think I'm moving towards an answer here. I'd also like to talk about, so people are plugging in, those points as well, and the y-intercept someone's talking about. That's lovely. So far the poll is only going one way at the moment. So people voting in the Slido chat further up this page have all picked the same answer so far, and I think I'm leaning towards C as well. So okay, plugging numbers in, we eliminated options, and we got down to our answer, which one it has to be. I think we can actually sketch this curve if we wanted to, right? Maybe let's have some strategies. If it was a different question, I've just asked you, perhaps in an interview, perhaps I've asked you, could you start by sketching the graph y equals x cubed minus x squared minus x plus 1? And I haven't given you any options. Okay, let's pretend this is now an interview question and I've just given that to you as something to do. I reckon you can do that. Now you know the answer for this because you can see it on the board already. But I think you could work it out. Yeah, somebody's asked for what's the proper working for this. Now, I know that some people don't really like this idea of plugging in numbers and just checking which one it could be. So let's maybe try starting again. I mean, that does work. That gets us to the right answer, so we get the marks. It is C. People in chat, you are correct. Brilliant. Oh, everyone's voting C. But I think if it was an interview question and I'd asked you to sketch this, then you've got some strategies for sketching graphs like this, haven't you? And that starts by maybe checking some values. So checking what's going on when x is 0, perhaps, to find the y-intercept. But if you're sketching the graph without any options, you might try looking for where y equals 0. And that is a little bit tricky for this cubic, because we know a quadratic formula at A level, but we don't know a cubic formula at A level. There is a cubic formula. If you know the cubic formula, then I do not recommend that you use it on this question. The cubic formula is very complicated. Yeah, somebody in chat wants to work out the x-intercepts. I think that's what I'm going for. I want to work out the x-intercepts. Okay, so I need to spot some numbers here, I suppose. Work out some roots of this cubic equation. I suppose at A level you learn the remainder theorem and you learn things about spotting roots of cubics. So maybe you could spot that x equals 1 is a solution. That would be a good thing to spot. I can sort of see that from the shape of the equation, almost. This x cubed minus x squared reminds me of x squared times x minus 1. And this minus x plus 1 has kind of the same shape. It's things that differ by 1 power with a minus sign in between. So I'm sort of expecting this to factorise nicely. Times minus 1, like that. So that's, I don't know why I'm writing so sideways. Let's turn that around. There we go. Okay. So that would be my equation. This would be equal to 0 if y is 0. And then this is the difference of two squares. Difference of two squares. So that's x minus 1, x plus 1. Okay. So there's a repeated root at 1. Okay. Repeated root at 1. Nearby, this is positive, so looks like this, and then there's another root over at minus 1. It's a happy cubic, isn't it? Well, it's a cubic that increases for large values of x. It's going to do something like that. I say happy cubic for that sort. I'm thinking about happy quadratics and sad quadratics and trying to extend that theory a little bit to cubics, which doesn't really make sense because that doesn't really look like a happy face, does it? But, you know. Okay, so I've got to a cubic like this. 1, 1, minus 1, so I can draw a picture like C. Okay, and I promise you I did that without looking at the picture for C. Okay, right, good. Very nice. Thanks for voting in that poll. Okay, so this has got some of the elements I like about a map problem. It's a curve sketching question, but there are multiple ways in because you can think about plugging in values or looking for special features. You can think about the difference between the pictures that you've been given. You can do some algebra, which involves messing around with cubic equations and deciding for yourself that you want to look for the x-intercepts rather than being told. There's a bit of lag on the stream, so people are still suggesting cubic methods of dealing with cubics, which is good. Okay, good. Can we do polynomial division? Anything's acceptable for the multiple choice questions. What's the maximum at x equals minus 1/3? Oh, you're right. I've drawn my picture quite badly. I've drawn it with a maximum at 0, but that's not actually true, is it? The maximum might not be at 0. It could do a bigger value somewhere else. And in fact, this is actually the answer. The maximum is actually somewhere else. Let's quickly revise how you find the maximum. I differentiate the curve, differentiate the equation of the curve, and set that equal to 0 to work out where the turning points are. If we do that, oops, sorry for the handwriting. If we do that, then we'll get some quadratic equation to solve for where the turning points are. We actually know there's a turning point at 1, so this this is going to have quite nice roots, isn't it? We know there's a turning point at 1 because there's a repeated root at 1. Well, we know there's a point with 0 derivative there. Okay, so it's going to be 3x. Somebody in chat's already told me what this number's going to be. It's minus 1/3. And that works out, doesn't it? Good, okay. Okay, so my picture, not quite perfect. Okay. Quick breather. Whew, right, short questions. Good, I like it. People have asked me in chat. Somebody's asked, do I create the questions for what will be on the mat? And do I create the mat questions? I write some of them. Last year I wrote about half of the short questions. This year I've written some of the mat questions. I'm not sure I'm allowed to say which ones I've written. I'm in charge of making sure they get set by someone. So I, with other colleagues in Oxford, together there's a panel of us who write the questions. But yes, some of them are my ideas. This one was not my idea. This one was from long before I worked at Oxford. Right, okay. Good, quick breather. Okay. I like this one. I've got another short question coming up. The idea is that we've got, I guess, 2.5 hours to do the mat. There's 10 short questions, and you do 4 longer questions. We'll look at a longer question in a minute. Let's throw another short one on the screen. Okay, this one's a bit harder. It's also from 2011. It's question 1H. So the 10 multiple choice questions are in question 1, A, B, C, D, E, F, G, H, I, J. And usually the ones at A and B are more straightforward or easier to see what you're supposed to do, and the ones further down towards H, I and J are more complicated and look more unfamiliar. Now it's a really good skill to be able to look at unfamiliar mathematics, something you've never seen before, and work out how to get started with it, work out what you're going to do. And maybe that involves trying out things that don't work. Maybe it involves getting stuck or lost or just exploring and just trying anything that works, whether or not you can see where it's going, to try and get unstuck. It's a really important skill to have on a mathematics degree. It's a really important skill to have if you want to solve lots of problems. And it's an important skill on the mat because some of the questions look really unfamiliar, like this one. We've got x equals, and then the equation on the right is just almost crazy. It's 8 to the power of logarithm base 2x minus 9 to the power of logarithm base 3x minus 4 to the power of logarithm base 2x plus logarithm base 0.5 of 0.25. Whew, big breath. So, if you haven't seen logarithms before, then at some point you will learn about logarithms on A-level maths or equivalent. If you're watching this at the very start of year 12, then great to have you with us. Nice to see you. You're going to learn about logarithms, I hope, and Matt uses content from year 12 single mathematics, so logarithms. Nobody in chat has yet said what's a logarithm, but I'm going to keep explaining them anyway. The idea of a logarithm is if you've got a to the power of b equals c, then you can write b is equal to log a base c. Okay, so it's a way to say what's the power that I should raise a to in order to get c. So when you read this, you're saying, oh, b is the number that I should raise a to the power of to get c. And then there's some stuff to do with messing around with powers and indices that we're going to explore today. Okay, good. Right, okay, so possibly people are looking at this question and absolutely stuck on what's going on. And I'm going to give you a moment to be stuck on it. Being stuck on questions is good for you. This is from 2011. We've got all the past papers back to 2007 on our website, on that Matt website that I linked to earlier. Link is in the YouTube description as well, and all over this page, hopefully. We've got the past papers back to 2007 and the solutions, but I almost don't recommend looking at the solutions because I recommend getting stuck on things and not letting yourself cheat and look at the solutions. Be stuck on it for ages rather than being stuck on. Be stuck on it for ages. Look at something else. Come back in a month. Find out. Oh, have you had a good idea now that you've learnt what logarithms are? Somebody in chat says they've just learnt what logarithms are. So I'm pleased to have helped you like that. If you want to know more about logarithms, there's a matlive stream episode. Actually, I suppose it's called logarithms. That includes That includes revision material, which for you could be learning about logarithms really quickly. I've put some bullet points in, like this one, about everything you need to know about logarithms, and some warm-up problems. The warm-up problems are supposed to be for people who already know about logarithms, who are warming up to do some math questions. But for you, if you've never seen logarithms before, and you want to sneakily get ahead of your class, then you could look at my revision notes and try the warm-up problems as a way to check whether you've learnt about logarithms. Right, okay. Sneakily teaching people about logarithms. Good stuff, good stuff. People are telling me in the chat how I can simplify this object at the end. Logarithm of 0.5 is 0.25. Okay. Hang on, let's just remove that advert. Okay. Good. Okay. So this thing at the end, people are reading this and thinking, this is the number that I should raise 0.5 to get 0.25. And I know that number. 0.25 is what happens when you square 0.5. It's 1/2 times 1/2. So that means that this thing here, this is just 2. 2 is the answer to what number should I put up here to make this equation true. Okay, good. So that's just 2. People are working out the solutions in chat. People in chat way ahead of me. Okay, good. I'm going to turn on a poll. To make it harder for chat, I've turned on a poll, but its results are hidden, so you can't copy each other's answers. Except people are already putting their answers in chat, so you could copy them, I suppose. Okay, that's just 2 on the end. And we can simplify the rest of the terms as well. So at the moment I'm just messing around with each of the terms to try and work out what's going on. I don't know where this is going, except I'm trying to simplify things. This looks really complicated. If I can simplify that, it'd be really nice. Here I'm thinking about how this is to do with powers of 2, and powers of 8 are secretly just powers of 2, aren't they? Because 8 is 2 to the power of 3. So I can do some power stuff. To say this is 2 to the... So this is just x to the power of 3. Okay, so I can rearrange the powers like this. Some people know facts about logarithms that makes this slightly faster. If at this step you wanted to bring the 3 inside the logarithm, then congratulations, you know some facts about logarithms. And it speeds this up just a tiny bit. So you can do some logs one step faster, I think. Okay, cool. That's just x cubed. And now I'm excited because I've simplified this term down to x cubed. And this looks a bit like I might be able to simplify the whole equation, maybe, if I'm lucky. Yeah, okay, so I've got some ideas now. This one turns out to be equal to, that's x squared, following a similar logic to the previous one. For log 2x, this is going to be exactly the same with different numbers. This is also x squared. Yes, okay. Yes, somebody in chat simplified the x squared one. No, yes. It's a bit complicated with all the powers. Log base 2x, 2 to the 3. Yes, okay. Someone in chat's put them in 2s and 3s. They've done a halfway step for me. Yes, 2 to the power of all of this stuff. And then brilliantly, you can simplify that a bit more. Aha! Okay. So all of this has turned into x equals x cubed minus 2x squared plus 2. That's just a polynomial. And now I'm just looking for the number of positive solutions to this cubic. But I've got another cubic to solve. Let's go. And people in chat are having a good go at solving that one, which is very nice. Okay, good. Okay. Question come in. Do you get marks for working out on the multiple choice questions? And the answer is no. For the multiple choice questions, it's just 4 marks for the right answer, no marks for wrong answer, or leaving it blank, sorry. In a moment, we'll talk about a long question where you can get marks for your working out. And somebody else has asked, when is the best time to start learning or studying for the maths? Good news, you are already learning or studying for the maths. If you're doing A-level maths or equivalent, or if you're about to start A-level maths or equivalent, then that's the studying that you need to do for the maths admissions test. It's not based on complicated mathematics, it's based on a very limited set of mathematics. And if you're trying tricky maths problems or thinking about maths outside the classroom, then you're already practicing the kind of problem-solving skills that we're looking for in the maths. So you might already be preparing for math without knowing it. we started doing Mat live stream stuff this year. For the people taking Mat this year, we started the live stream in about August over the summer for something to do over the summer, and I think that's when I would get really serious about thinking about Mat papers for something to do on the over the summer in between year 12 and year 13. Of course, you can look at stuff before, you just might not have seen the year 12 maths yet. Okay, we've got a cubic to solve. Some people in chat seem divided between whether this is going to have 2 solutions or 3. It's about 60-30 at the moment, between 2 solutions and 3. So if I rearrange it, like x cubed minus 2x squared minus x plus 2 equals 0. And again, I think I can factorise this one. And it's got x squared minus 1 as a factor again. So the roots are going to be 2, x equals 1, or x equals minus 1. Okay, those are the roots of the cubic. So D, right? Well, no, because we're looking for positive solutions. We're looking for positive values of x. So, aha, we need to not count minus 1. We're only looking for positive solutions. Technically, that's because inside these logarithms, you're not supposed to put negative numbers in logarithms. They're not defined for negative numbers. If the base is positive, then this power can only be positive, so it doesn't make sense to take the logarithm of a negative number. There's just no solution for the number you put upstairs that would give you that logarithm. Okay, so log counting minus 1, I get down to 2 solutions, x equals 2 or x equals 1. And the poll was a little bit split on this one, about 75-25 in the end on the voting for that one. And I can see why you would pick C. It's very easy to get to this cubic and think, aha, 3 solutions because it's a cubic. Even better, you can solve the cubic, get your 3 numbers out. And yeah, no, it's almost correct, but one of them doesn't work. Peihan in chat wants to mention something about complex numbers. We're definitely not using any complex numbers on the mats. Okay, quick breather before we look at a long question. Moving on to a longer question. There's a question that's come in. How many marks is the mat out of? Easy to answer. It's out of 100. So there are, what did I say? There are 4 marks for each of the short questions within question 1. So that's 40 marks there. And then you also do 4 longer questions. Hang on, let's list that consistently. 15 marks times 4 questions on questions, the long questions that you're doing. That's 40 plus 60. Okay, so it's out of 100. I think that 70 or above is considered, I'd consider that an okay to good score. But there's no hard pass-fail mark. There's no sharp, you need this many marks to go to Oxford and fewer marks. It doesn't work like that. Because we look at the rest of your application. We look at your predicted grades, previous academic record, we read your personal statement and your teacher's reference, we get some other information. We're particularly interested in the context around your application. If there's important contextual information we should know. The pandemic's been different for different people in different ways. Then that could be really important. So we don't have a hard pass-fail mark. We look at people's applications in context. Okay, so we usually shortlist people with an average score of about 70 or more or less. If you dig into the MAT website, you can find histograms of different outcomes by MAT score to see last year when we shortlisted, who did we shortlist and what happened and what were their MAT scores. Okay. Yeah, so a question's just come in, what is the cutoff in general? And there's no hard cutoff. Might show you some histograms at the end of this workshop if you like, to try and demonstrate that there's no hard cutoff. I get this question quite a lot, and I've started saying about 70, but really we shortlist people with lower MAT scores than 70. We shortlist some people with MAT scores that are very low, and we shortlist people with MAT scores that are very high. It's not the only factor we look at. It's important because it helps us distinguish between people who are really good at maths, but it's not the only thing. Okay. Someone in chat, all caps, we want to see histograms. Right, okay, we're going to see a MAT question, and then we'll look at some histograms. Okay. And the question, should the reference be preferably from our maths professor? it doesn't matter so long as it tells us about why you'd be a good student on a maths course. Sometimes it's written by a head of sixth form, or sometimes it's written by different teachers working together. Sometimes it's written by a UCAS referee who's not associated with school or college. It doesn't matter so long as they give us useful information and about you as a student. Okay. Yeah, I want to see some histograms. Okay, people want to see the histograms. I hear that. We're going to look at some histograms. Okay, we're going to think about this long mat question first. We've got half an hour. Okay. Right, here we go. So, suppose that x satisfies this equation. And we're given a cubic equation. This one does not have nice solutions. So, we're not going to be asked to work out what this number is. We're just told that it satisfies this equation. Okay, so it's one of the roots of this equation. I don't know if this has got multiple roots. I'm going to have a very quick think about whether this has got multiple roots or not. I don't know. Right, okay, good. So we're asked to show that some things. This is a property of long questions. So questions 2, 3, 4, 5, 6, 7 are the long questions on MAT. Each applicant does 4 of those long questions. More information about which ones you do, boring things like that, on the front of the test paper or in the MAT advice video or on the MAT page. Anyway, the long questions want us to show that things are true. They ask us to explain our reasoning here, show that down here. So we're told what the answer is in a way, right? We're told that we're trying to get this. We've got to work out why that's true given the information. We're not given very much information here. We're just given the information x satisfies this equation. So we're going to work out why is this true and why is that true. Goodness me. Okay. This question has then got a second part. It's got 2 more parts afterwards that we're going to talk about in a moment. But first I want to just think about this first part. Let's see if we can have the right idea. Okay. Tool 3 histograms. And just to answer the question that's come in, I'm going to type it as well so that people can see it. The MAT live streams are at they're at 5 PM UK time, and yes, they're recorded for people to watch back afterwards. You can stream them anytime on the matlive website, www.maths.ox.ac.uk/r/matlive. Matlive. Right, okay. I promised that it's not just adverts for the live stream. We're also going to do this question. Right, okay. Yeah, okay, while you're having an idea, there's a good idea in chat. An anonymous person has said, good idea, multiplying by x. Multiplying by x looks really good because if I take my glasses off and squint, then this equation over here looks a bit like the left-hand side looks like I've multiplied by x, and the shape on the right looks a bit like I've maybe multiplied by x. So it's looking pretty good. In fact, that's what's happened, isn't it? If you multiply this by x, you get equals 2x squared plus x multiplying by x. Okay, because I'm doing a show that question, I'm trying to explain what I'm doing or trying to explain why things are true. Rather than just writing them down. So x to the 4 equals x plus x. Just switch the terms around, hasn't it? Okay, there we go. Good, brilliant. Okay, really recommend writing a few words in. Just a if then so, sort of just those short words if then so can really help explain what you're saying when you write down your maths. It should sort of work as a sentence in a way, where if you read it out. You probably can't read it out loud during the exam, but if you read it out, then it should work. Mine doesn't at the moment, does it? So I could put, we have x cubed equals 2x plus 1, so x to the 4 equals 2x squared plus x, multiplied by x, in brackets. So x to the 4 equals x plus 2x squared, full stop. I'm not going to explain that that's just swapping the terms around, because that's pretty obvious. Okay, good, right, I think I've explained that. And look, I didn't have to write very many words, right? It's not like the people applying for English or something. Okay. Yes, okay. And people have got brilliant suggestions. Yeah, multiply in by x again. It was a big success the previous time. Let's just try and see what happens. If we multiply by x again, I'm taking that one and multiplying by x again. Well, I haven't quite got what I wanted. Yes, okay. So, I haven't quite got what I wanted. So I needed a second idea. People in chat, Belinda's told me that I can plug in, we knew what x cubed was equal to from the equation. So I'm going to write this, and x cubed is equal to 2x plus 1. So I can plug it in. X to the 5 equals x squared plus 2x plus 1, and then multiply that out. And I get, aha, brilliant, I get this thing that I'm looking for. Okay, I'm not even going to rewrite that one in that order. Okay, lovely. Yeah, sub in x cubed. And somebody's asked, are arrows of implication enough for show your working questions? I've seen these, they look like this, right? People draw these. I think if you know what they mean, and you're comfortable that you're going to get them right, then that can work. I'm a bit nervous, because I'm sure you know what you're doing, but some applicants don't know what those symbols mean, and just write them down the left for every single line, even when they don't really mean A implies B, and then their working doesn't make any sense at all, because they've claimed that things imply each other when they don't. So if you know what those arrows mean, then you can use that, but please don't use them as just a new line symbol down the left hand side, unless you mean that. Okay, good. Prove the first part by multiplying by x and then reducing. For the second part, employ the same idea, use it with induction. Okay, yes. I suppose that is a little bit like induction. Okay, yes, brilliant. Okay. It's using the previous result, isn't it? Which is the main idea of induction. I'm not really sure if people have seen induction or not. Okay, right. I'm going to try not to mention induction for the rest of this question. See what happens. Okay, part 2. We're done with part 1, I think. Somebody asked about the mark distribution. So the mark distribution is not printed on the question. We don't tell you which parts of the question are hard and which parts are easy by giving you the number of marks that each part of the question is worth. In fact, there is a mark distribution. I don't know it. I'm going to look it up while we think about part 2 of the question. I haven't memorised it. Sort of thing that I should have known before I went live. That first part of the question was worth 2 marks. I think we got a mark for the first part for doing the explaining. I think the mark's not for getting to the final answer, because the final answer is printed in the question. The mark is for doing the explaining. And then we'll get a second mark for explaining this one. Okay, this next part of the question is going to be worth 5 marks, which is quite a few. So let's have a think about that now. Okay, I'm back. There we go. Good. Okay. Right, so it tells us for every integer k that's bigger than or equal to 0, we can uniquely write, okay, we're being told a fact, x to the k is equal to ak, so some like sequence of numbers, capital A, there's an a0, an a1, and a2, plus some other number, these are integers, whole numbers, times x plus some number times x squared. I see, and that's sort of what we've shown in the previous parts, that when k is 4, we're talking about x to the power of 4, and we've shown that that's equal to, well, we showed it was equal to x plus 2x squared, which is like having a 1 in here, a 0 here, and a 2 here. Okay, so that's 0, 1, 2. And then a5, b5 and c5 tell us something about k equals 5, which is x to the power of 5. The coefficients now are 2, 4, 1. So that's 2, 4, 1. Okay, right, good. Here's the question. Show that, so marks for explaining, not really marks for copying out what's in the question, marks for explaining why ak plus 1 is equal to ck, bk plus 1 is equal to bleh, and ck plus 1 is equal to bleh. So these numbers relate to, yeah, I suppose this looks complicated and different. It's not like things that I'd seen at A level, where all of my sequences at A level were just, you have one sequence, right? And ak plus 1 is something to do with ak. Here we've sort of got, if you really think about it, we've got 3 sequences, A, B, and C, and they all relate to each other, apparently. That's what we're trying to prove. So probably all of the stuff that I know from school about having one sequence is probably useless, because I've got 3 sequences, which is just completely different, isn't it? 3 sequences that seem to be working together, so goodness knows. That's actually quite good news, because it means that I'm probably not going to use any advanced sequences ideas. I'm probably just going to work out what these coefficients are. Okay, so let's take exactly the same idea that we had before. Let's multiply this expression by x. The reason I want to do that is that I can see that on the left, that's going to turn an xk into an xk plus 1. It's going to be the thing that relates together k plus 1, which is something to do with these coefficients a, b and c, subscript k plus 1, relating those to the coefficients ak, bk, ck. Okay, yeah, George and Payan in chat want to multiply by x, and they've got ahead a little bit. They want to, they're worried about this x cubed that's going to turn up, and they've got a way to deal with that. Let's write this down. I'm just going to change colour to make it more obvious what I'm writing. Okay, x to the k plus 1 is equal to ak times x plus bk, let's make that x look like an x, there we go, bk times x squared plus ck times x cubed. Okay, that's pretty good. I also know a fact about x cubed, don't I? That's the only thing I know a fact about, right? It's 2x plus 1. So I could use that to simplify things a bit, like we were doing before. So like how these coefficients related to the previous ones because we just multiplied by x and then simplified. I could do that here as well. And I'm not sure, as I write this out, I'm not sure if this is going to work or if this is going to give me what I want, but hey, it feels like I'm simplifying something, which feels quite good. Okay, so that's ck as the constant, and then in my coefficient of x, I'll get ak plus 2ck. This is looking good. Plus bkx squared. Okay, almost there, but don't get too excited. We've now got a quadratic with the right coefficients for the right-hand sides. All I need to say now is that also, my writing's going everywhere on this one, sorry. Also, x to the k plus 1 is equal to ak plus 1 plus bk plus 1. This is what these numbers mean. The ones with k plus 1 on the subscripts, the small letters down below. That's what the k plus 1 variables mean. They belong in here for this statement for x to the k plus 1. So I can compare coefficients. Just to be really technical here, I've got the right coefficients and I'm comparing those with what x to the k plus 1 is equal to. Comparing coefficients. Okay, that gives me exactly these three relationships. Right, okay, good. We're doing really well. We're doing great, gang. This is fantastic. Who's still with me? Oh, yes, people are still here. Good. Okay. Right, okay. I was worried. Okay, we're halfway through the question. We've picked up 7 marks so far out of 15. That's pretty good. Let's get some more. Sorry, next part of the question. I'm going to have a cheat and look at the solution quickly, enough to see. This next part's also worth 5 marks. This happens sometimes, that there'll be a start part of the question that might be worth just a couple of marks to get you in, and maybe the last part of the question is just relating previous things together. Okay. Sometimes the last part of the question checks whether we've understood something big about the question. Sometimes it's just one more calculation to do. Okay. This says, let dk be equal to ak plus ck minus bk. Okay. Okay. Show that dk plus 1 is equal to minus dk. Okay, right. So this is something to do with... The first thing I think when I see this, I mean, again, it's to show that question, but the first thing I thought when I saw this is that, well, this dk plus 1, you know, we only just introduced these d variables. I really want to just split that up and talk about what is this? In terms of the things I know about, it's this, right? And now I've got ak plus 1 plus ck plus 1 minus bk plus 1. That's just brilliant, right? Because I just proved in part 2, I just proved something about these 3 numbers. I can't remember what it was. I'm going to have to go and look back again. Yeah, okay, I proved that they were equal to something in terms of AK, BK and CK. Perfect. So I'm going to use part 2 to simplify this in terms of AK, BK and CK. And now I'm pretty sure that that can't possibly go wrong. I'm going to plug the things in and rearrange stuff, and hopefully that will just turn out to be minus AK minus CK plus BK. I'm hoping for the minus signs in there because I'm hoping for minus DK. Okay. I really like this because we've been given a new definition, but immediately we can just express it in terms of things that we already knew about. So we can do that algebra just using part 2. So really, I suppose this part of the question is checking, did we understand the previous part? to apply it here. Okay. We did that algebra on autopilot, I suppose, before, just checking what happens when we multiply by x. But here, we're just using what we found out. Okay, this works out. I'm not going to do the algebra on the screen. Okay, here's a good word. Here's the word hence. Hence always means using the previous fact. Or, I suppose, so, using that thing we just did. So this says show that dk plus 1 is equal to minus dk, and therefore, or using that knowledge, show that this is true. So I've got to stare at this a little bit, because this says ak plus ck is equal to bk plus minus 1 to the k. What's that got to do with anything? Isn't that just some other combination of a's and b's and c's? What's going on there? Let's have suggestions in the Slido chat, please. What on earth is going on here? We want to use the previous fact. So the previous fact was that dk plus 1 is equal to minus dk. Okay. And we use that fact somehow in here. A little bit tricky to see how I'm going to do that. I'd like a suggestion, please. Oh, there's a bit of a lag on chat, isn't there? Right, okay. You're probably already typing. Good. No wrong answers, I think, at this point. Just exploring what we can do. Okay. I'm saying okay quite a lot. There's a lot of K's around, which is making me say okay. George has got a suggestion in chat. George says something about there's a minus sign in here. So each dk plus 1 is minus dk, and that's doing some switching signs, so that you pick up minus 1 to the power of k from doing lots of minus signs, lots of sign switching as you go down. I think that's a good idea. Let's rearrange this very slightly. What we're asked to show is that ak plus ck minus bk is equal to minus 1 to the k. I've done this pretty trivial rearranging. I've moved the b onto the left, just because this object here, these three things together, is exactly dk. Okay, yeah, so this is equivalent to showing that dk is equal to minus 1 to the power of k. Aha! Aha! Yes, and Belinda points out a really good fact. We know d4. In fact, we also know d3 and d2 and d1. We know the small values of d because we know the values of a when k is a small number. We know some early on numbers. Brilliant stuff. Yes, Ardra in chat also says that we know that the dk ones just alternate signs. Yeah, dk plus 1 equals minus dk. Good, okay. So they all work together. We know that dk is equal to, what's d? Okay, so d4, Belinda told me, was 1, which I believe because it's 0 plus 2 minus 1. When we put the number 4 in, we actually know these numbers. This is 1 plus, no, come on, get it right. 0 plus 2 minus 1 is 1. Okay. In fact, we can check that d5 is equal to minus 1. So d5 is 2 plus 1, no it's not. 2 plus 1 minus 4. Quick maths is minus 1. And d6 is equal to minus d5 is 1. I'm now using the fact d7 is minus d6 is minus 1, and so on. dk is equal to minus 1 to the k is this fancy way of writing minus 1 if k is odd and plus 1 if k is even. Okay, if you haven't seen this before as a clever way to write minus 1 if k is odd, plus 1 if k is even, then aha, you've seen it now. You can use it in other stuff as well. Okay, brilliant. So I think really spotting that this thing involved dk at all was a good way to make progress with this question. And then picking up all these minus signs just by zippering down, ooh, d10 is equal to minus d9, is d equal to d8, that's equal to minus d7, which is d6, which is minus d5, ooh, all the way down. Brilliant stuff. Okay, last part of the question, and then we'll look at some histograms. Defines another new thing. We've had A, B, C, D, and now we're going for F. So we've skipped E. Now we've skipped to F. fk is equal to ak plus 1 plus ck plus 1. That's a little bit odd, isn't it? It's defined in terms of the next one up variables. Okay, so this is ak plus 1 plus ck plus 1. We're asked to show that. I don't know anything about f except that it's defined like this. It's ak plus 1 plus ck plus 1. Shall I try and write this out using a's and c's? Or hang on a minute, I already had an a plus a c. I already knew that this sort of a plus c object was equal to b plus minus 1 to the k. I can use the previous part of the question. I'm not sure if this is helpful. This is b k plus 1 plus minus 1 to the k plus 1. Seems quite good. Okay. Yeah, maybe they skipped E because E represents energy sometimes in physics. Yeah, okay. Or maybe they used F because the resemblance here is to the Fibonacci numbers, which start with F. Maybe, okay. Who can say? Right, where am I going with this? I think I like the way that Fk is equal to bk plus 1 minus 1 to the k plus 1. But then also, I like thinking about things in terms of k plus 2 variables, don't I? I'm worried about the way these have got different subscripts on, which might make it hard to compare things together. Any suggestions from chat, still welcome if you want to join in with this part of the question at the end. How am I going to compare these things together? I'm a little bit worried. Maybe I shouldn't be worried. Maybe it's all fine. Yeah, I think it's going to be fine. Okay. Does fk equal dk plus 1 plus bk plus 1? Oh, that's true. Yes, that's a true fact. Fk is equal to dk plus 1, the previous object, plus bk plus 1, one of the original objects. That's nice. George has got a suggestion that we already know ak plus 1 in terms of ak, which I think is just about true because we know it in terms of ck, which is related to ak, and bk? Something like that, isn't it? Let's see if I can plug some stuff in and see what happens. Yeah, I'm a little bit worried about all these factors of b. Let's give it a go and see what happens. Okay, I'm going to replace this fk over here with bk plus 1. Do I want to do b's or do I want to do c's? A little bit worried. No, it's fine. It's fine. And then I've got a bk plus 2 for the next one. So my thinking here is that these minus ones will cancel, which seems nice because one's a plus 1 and one's a minus 1. So that's quite good. I'll get down to a bk plus 1 plus bk plus 2. So I know a relationship about b's. I think I do, but I think it's quite complicated, isn't it? Yes, I know this b is a plus 2c for the previous ones. I'm not sure I like that right now. Okay, I think I need another idea. Oh, maybe not. Because, hang on the right, this is the left-hand side. This is going to be the right. I've got f of k plus 2. I think my idea is just to relate things into the a's and b's and just see what happens. That's, what am I going to write? A k plus 3 plus c k plus 3. So this is looking pretty good. Except for that line. That line's looking terrible. Okay. Someone in chat just says yes. I've forgotten what I was saying 20 seconds ago when you said yes. People want to use the ak plus 1s to simplify. Yeah, okay. Oh, maybe I should have done this question beforehand. No, terrible idea. Never do the questions beforehand. I'm going to try and simplify these ones. I've got fk plus 2 is equal to ak plus 3 plus ck plus 3. And I do know some relationships for those things, right? I know that ak plus 1 is ck. So this thing is ck plus 2 plus, oh no, yeah. So that one is ck plus 2. And then this ck plus 3 is equal to bk the previous one. Okay, that looks pretty good. Am I done? I think I'm not quite done. I've got a bk plus 2 on both sides now, using this fact about C's. Yeah, then I can use this fact about C's. This ck plus 2 is equal to bk plus 1. Okay, so on the right hand side I've got bk plus 2 plus bk plus 1. Right, okay, I didn't need to worry about it. It's all worked out just fine. By just writing stuff and trying to get things in terms of b's, it's worked out. I've got a bk plus 1 plus bk plus 2 on both sides. Okay, so left hand side equals right hand side for all k. Ah, lovely. Okay, good. Things did simplify down in the end to the same thing. I got really worried about these a's and c's. Maybe there's a way to do this using the d variable that was introduced. I suppose we used it in here to prove this fact. People in chat were going for some dk approaches, but yeah, cool. Simplifying things down. Okay. Good, right, okay. That was the end of that math question. I think we got there. I got really scared during that last part, but just keep simplifying things, apparently. I learned to think today. That's nice. I've got all my advice on the screen for the last couple of minutes, and I promised I'd show you some histograms, which I'm going to do now. Let's have a quick look at some histograms. So on that website at the bottom there, link is that website there, next to my face. Link is in the YouTube description, and the links for Matt past papers. The page looks like this. Here's my Matt page. It's got a link to the Matt live stream. It's got the Matt advice video. It's got some practice questions, if you want to do some practice questions. And it's got a big table of past papers. The past papers include the paper, some worked solutions, which gives one way to do the question, might be other ways to do the question, and something called a feedback document. If you open the feedback document, then you can get some numbers about the course for that year, the admissions that year. And if you scroll down, you can get this lovely histogram of people's outcomes by Matt score for, this is for maths and stats, maths and philosophy, all considered together. Okay, let's put that a little bit bigger. You wanted histograms? Here's a histogram. It's got Matt score along the x-axis, big Matt scores, small Matt scores, and the stacks are people. The coloured in bar is for people who applied but weren't shortlisted. So you can see if you've got a lower Matt score, then probably you applied but you were not shortlisted, with some exceptions. The uncoloured blank bit of bar is for shortlisted but no offer. So those people were shortlisted for interview, and then after the interview, together with their interview grades, we looked at their entire application and decided not to make an offer to them. And then these kind of shaded bits at the bottom are people we made offers to. So I think you can see that there are some exceptions. There are people we shortlisted with lower Matt scores, but around about 70, it seems like you've got a good chance of being shortlisted. If you think about it like chances, I mean, it's not chances because it's not random, but people with high Matt scores are almost certainly shortlisted for an offer. Shortlisted, and lots of them were made offers. Not actually all of them, but lots of them were made offers. In general, I say the bigger the Matt score, the better, but no hard cutoff. If there was a hard cutoff, then the bars would switch from black to white and grey straight away, and they don't. There's this nice shape to the histogram in there as well. Okay, good. When you're self-marking, how many marks do you know to give yourself? It's a fair question. I suppose you can't really know for sure, but if you got all of the working out, be fair to yourself. If you got the right ideas, then you probably get the marks. If you missed some technicalities, then you probably lose marks. Sorry. Okay. Can you imagine getting bigger than 96% on the map with no offer? There was also an interview involved in there. Should we aim for 81 to 85? Sarcasm. I mean, aim for the stars. And if you miss, you'll be among the. How's that saying work? Oh, you're allowed to work from. Someone's got a question about my working from left hand side and right hand side. Yeah, that's allowed. Yeah, if you can rearrange both sides and show that they're equal, then blah equals the same thing as blur, so they must be equal to each other by transitivity. That's allowed. There you go. Maths fact. You're allowed to rearrange both of them and show that they're equal. As long as everything's reversible, then you're fine. Here, all of my algebras refer to just true facts. When should we start past papers? Says someone in chat. the start of the IB is probably too early because you probably haven't learnt about logarithms yet. As soon as you've learnt about logarithms, you could try some questions with logarithms in. And then midway through IB, in the summer before you apply, you've probably learnt enough maths now to try some math questions. Should be good. That's the saying, thank you. Shoot for the moon, and if you miss, you'll land among the stars. That's the saying I was going for. It's because I started with the stars, and then I couldn't remember where else you could go. How do we decide who to shortlist among the lower math scores? Which is a really good question. We look at your whole application. So we look at we're looking out for people who are really promising, but maybe due to the sort of context around their education, there's a really good reason why they didn't score higher in the maths. So there's some people down here who, I'm not going into particular cases, but name no names. There are some people where there was a really good reason where we thought, okay, this person's got a lower maths score, but we think they'll do really well on our course. And doing really well on our course is the main thing we're looking for. Okay. Which could be a lot of different reasons. Okay, right, back to my advice slide. I'm overrunning a little bit, but I'm just going to do the last couple of questions that have come in. Somebody wants to talk about if I'm not wrong, then I believe the equation has 3 real roots. And I'm really sorry, but I think you might be wrong. I think it's got 2 real roots. Or the one that had, ages ago, was it the one that had 3 real roots, but one of them was negative? Anyway. Can we use abbreviations? Somebody wants shortcuts. Okay, last question. Shortcuts in terms of notation during the maths, and abbreviations. I suppose so. If you do it, we will try our best to understand what you mean. If you write abbreviations and really tiny and short and fast, then we will do our best to understand. I've got graduate students marking it. They know lots of mathematics. They're quite good at working out what you mean. If you can help them out, then just gives you a little bit of an edge, doesn't it? If you can help them understand what you've written. Yeah, okay. Good. But yeah, if you're in a real hurry, then writing down anything is better than writing down nothing. So you do you. Maybe if you've got more time at the end, go back and help us understand what thing you were saying. And last 2 questions, I guess. Do you find out your math score before interview? You do not. You get an automatic email with your math score at the end of the process in January, but you don't find out your math score at interview. You don't need to know your math score when you come to interview. You've been shortlisted for interview. Time to think about interviews. And someone says, will we have similar sessions in the future? Which is why I've got this on the screen. This is similar. We're live every Thursday doing stuff like this, talking about math questions, looking at warm-up materials, trying our best to help people prepare for the maths. All together, live online sessions. It's quite casual and laid back and fun. We do lots of maths. Some of the people in chat are also, I've seen at live stream sessions. They've been saying that it's good. So thank you for the endorsement of people in chat. I'm going to stop the live session there. Hope to see some of you on a Thursday, 5 PM UK time for some live streams, or watching the replays, or whatever you want to do. If you hate me and you just want to look at the worksheets, then that's fine too. The worksheets are there, and you can pretend that I didn't write them. But I think I'm going to end the live stream here so that I can go back to answering admissions questions in the open day. Enjoy the rest of your day. Enjoy the rest of the open day if you're hanging around for more of the open day. And see you around. Goodbye. Yes. 1 million out of 10 recommend. There we go. That can go on the website maybe. Right.